Alright, this is the lesson for 1.6, and this is actually the last lesson of chapter 1. So this is all about two-dimensional figures. It's just kind of an introduction into polygons, and two-dimensional polygons, that is. So a polygon is just another name for a shape, and there are special cases to polygons and things that make up a polygon. We'll get into that in a little bit. But right now we're going to talk about, there's two types of polygons. You can either have a concave or convex polygon. So concave, think of it as concave as the shape is kind of caving in. Alright, so if you look at this first figure, notice how this side is kind of caving in. And the way we can tell is if you draw a straight line along each side of the border, like this, if you were to go along and draw a straight line. If at any point while doing that, you get lines that go inside of the shape, like here, 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 that determines it as concave. Alright, so this would be an example of concave. Think of it as the lines go inside of the shape, it's concave. Now this one, if you did the same thing, draw a line kind of bordering that shape, as you can see, none of the lines are inside of that polygon. So that is an example of convex. Alright, so that's concave and convex. Real quick, there's kind of three important keys that we look at as non-examples of polygons. If you ever get a shape that kind of looks like this, where it has an opening, that's an example of a non-polygon. Another example is if you had kind of a shape that has rounded edges, that's not a polygon. And the other one, if you have like a shape that crosses. So these are non-examples. Oops. So that last one, you can't have any sides that are overlapping. Non-examples. Can't spell. There you go. So those are three non-examples. Other thing to mention, a regular polygon is when all sides and angles are congruent. Alright, so this would be an example of a regular pentagon. It's 5 sides. Each side's the same and each angle would be the same as well. And this, I would pause the video so you can copy that down. Alright, so that is just kind of name for each side. So anyways, next it says name each polygon by its number of sides and then classify it as convex or concave. So first thing, we got to count up how many sides. This is an octagon because it has 8 sides, and if you were to do this, you'd realize none of the lines go inside of that shape, so that is an example of convex. It's an octagon and it's convex. Also, another thing to mention, if you notice, it wasn't asking for this, but this would be an example of a regular octagon. Each of those sides are the same, angles are the same as well. Alright, this one, if you counted them up, it would be an octagon as well. Octagon, and if you did go here, you would realize that the sides go inside of that shape if you were to draw those lines around the border. So that's an example of concave. Kind of caves in. Alright, and then the next one, counted up the sides, you would realize it is a decagon and it is concave. Right, because if we were to draw those lines, once again, it's inside the shape. Next, hexagon, and it is concave. Alright, so moving on, next, these are the formulas that we need. So I'm going to write, this row is the perimeter, and this is the area. Alright, and then these are the formulas for triangles, for squares, rectangles, and circles. Alright, that might be a good idea to pause it there and just copy all of that information down, stuff that we need. Alright, just to actually go into more detail of what each of those letters and variables represent, I'm going to go for triangles. That's represented as the height, and when it refers to the perimeter as A plus B plus C, that's just referring to the three sides of the triangle. Alright, and then next to square, S is just each side. Remember, squares, all those angles are right angles. Rectangle, all the angles are right angles. Just to let you know, this side would be length, and this is width. And then with the circle, the R is referring to the radius. Right, so R is the radius. So those are all the formulas that you need for this lesson. Next, it asks us to find the perimeter and circumference and area, perimeter or circumference and the area of each figure to the nearest tenth. Alright, so real quick, perimeter of that rectangle. The perimeter is 2L plus 2W. So we get 2 times the length, which is 3.2, and 2 times W, which is 2.1. Alright, so if you simplified everything and added those together, you would get 10.6 cm. So perimeter is 10.6. And area is length times width, or we could write 3.2 times 2.1. Which, if you did that, you would get 6.7 cm squared. So that would be the area. That's the area, that's the perimeter. Alright, and then it asks for the perimeter of a circle. Remember, perimeter and circumference are the same thing. Circumference is just the perimeter of a circle. So we get C equals 2 times pi times R. And since we know the R is 3, or the radius is 3, we can just plug that in. So we get 2 times pi times 3, which if you did that in a calculator, you would end up getting 18.9 inches. So that's the circumference. Next, we got to find the area of that, and the area of a circle is pi times r squared. And once again, we're going to just plug in a 3 for r. So we really get 3 squared, which is 9. 9 times pi would give us 28.3 inches squared. So that's area, that's circumference. Alright, moving on. Next we have this largest area problem. It tells us Emily has 26 centimeters of cording to frame a photograph in her scrapbook. From the following shapes, which one would use most or all of the cording and enclose the largest space? Alright, so this is a tough question. It's asking, of these 4 figures here, which one is going to take up the most area? And we got to make sure that none of those perimeters exceed 26. Alright, so triangle to find the perimeter. Actually, I'm just going to give you the perimeter just because I don't have time to go through each one. So if you were to type all that in, type in the info into the formulas, you would figure out the perimeter of that triangle is 24, which is still less than 26, so we're good. And the area is 24.5. Area of, the perimeter, next one, part B, the perimeter of the circle, or the circumference, was 25.1, which is less than 26, so we're good there. And area was 50.24, or 0.2. Next one, that rectangle, the perimeter is 25, and the area is 36. Last one, the perimeter of that square is 26, and the area is 42.3, rounded. Alright, so you look at all those, which one, well, first off, all those perimeters are less than 26, or are at 26, so we're good there. So we just got to figure out which of those areas are the biggest. We figure out it's B. So that circle would have the largest area. Alright, last question. We have this triangle at -1, 3. I'm going to put P. Q is at -3, -1. And then R is at 4, -1. So we have this triangle. And we got to figure out what's the perimeter. What's the perimeter of that triangle there. So this is using distance formula, which you learned in 1.3. If you forgot it, remember distance formula is x2 minus x1 squared plus y2 minus y1 squared is the square root of all that. Alright, so I'm just going to find the distance first between P and Q. So we get x2, which would be -3, minus -1, that is squared, plus y2. Y2 is -1, and y1 is 3. Alright, so simplify -3 minus -1 is really -3 plus 1. -3 plus 1 is just a -2. And then -1 minus 3 is -4. Simplify all of this again. And -2 squared is just a +4. Remember, anything negative squared is a positive number. -4 squared will give us 16. So we get square root of 20. So that's the distance between P and Q, the square root of 20. And then next, I won't go through the steps again for that one, but the distance between Q and R would be square root of 41, and the distance between my bad, put the wrong one. Distance between P and R was square root of 41, and then the distance between Q and R was 7. So if you added those three up, you're going to end up getting 17.9. We're going to go units. So that's the perimeter. Alright, and remember, when you're adding up those square roots, you got to change those to a decimal first, and then you can add it, and you get 17.9 units. So that's the perimeter. Alright, so that was 1.6. If you have any questions, let us know. Thanks for listening. Peace.